Look down at your little cheat sheet. What do we have? We have, can't see that. We have two sides and the angle opposite one of them, right? Isn't that this scenario right here? Law of sines. We now know enough to solve this triangle. Okay, so what I'd say at this point is we need to kind of redraw, get rid of our nonsense. Kind of looks like this. I'll try and draw it right. That's 400, that's 38. This is 28.3. And let's just label them. Let's go. A, B, C. That's C, B, and A. Again, until you get a little practice, I would recommend you write out the law of sines, mark off what you know, what you're looking for. Okay. So I know A, I know B, I know angle B. Okay. What am I looking for? In essence, I'm looking for angle A, right? That one? Is that correct? Okay. So I'm using A over sine A is equal to B over sine B. I'm going to turn this over so I can write in that area. So A, oh wait, hold on, this is your homework.
Yeah.
Sorry, I thought I was moving into example. I'm not doing math on this. I didn't give that away.
Darn it.
Declan, I was counting on you to stop me there.
I wasn't going to stop.
All right, okay. Andy, didn't you say 8?
8, yeah.
Yeah, let's look at 8. Oh, time permitting, I do have a problem that's just like this one that I hope to work today. So here's number 8. 50-meter high antenna is mounted vertically on the ground. The slope's 13 degrees. It's a nice little problem here. Okay, so we have land. It's going like this. We have an antenna. I think we can assume that it is straight up and down since it's mounted vertically. Okay. Now we know the land is sloping 13 degrees. Okay? So that's our slope. We have two sides to this, right?
Yep.
Okay. So we're going to tie here, and we're going to tie downhill also. And that these are 53 degrees with the horizontal. So that is this angle right here. Okay. You are to find the angle. Okay, now let me move this 13 for you. I'm going to put it right here. That's a right triangle, right? We know this angle right here is 13. Can I also say that this is a right triangle? Is that a valid assumption?
Mm-hmm.
Yeah. That's going to allow you to get some more angles using your geometric principles. And I know this length right here. That's 50 meters. I think that should be enough to get you to solve it. Did that answer your question, Andy?
Uh-huh.
Okay. All right, number 9, 7, 9, 10. Okay, we got enough time for one problem, so let's work the one that's very similar to the one Andy just pulled out there. I really like this problem. You're going to have to think a little. Okay. So we are going to do problem 23 here out of this textbook. Okay. So let me just read it for you if you're in the back. A tree grows vertically. Okay, you got to pay attention to these small little details in here that are going to give you clues. A tree grows vertically on a mountainside. Further up the mountain, from a point 80 feet from the base of the tree, the angle of elevation to the tree top is 30. Angle of depression is 20 to the base. Find the height of the tree. Now remember, angle of elevation, right? I'm looking here, I turn up, that's angle of elevation. Angle of depression, I'm looking here and I turn down. Okay. So let's draw a sketch of this. So I have a hillside, and on that hillside, I have a tree. I want it to be a pine tree. We're going to hike up the hill 80 feet, right? We're going to hike up the hill 80 feet to some point about here. Now, I'm going to then kind of just, that's a horizontal line there. I know that the angle to the top of the tree, or the angle of elevation, is equal to 30 degrees. Angle of depression is 20 degrees. The whole angle is 50. We're going to have to figure out more information using our geometric principles. Remember, there's two of them that are very important: alternate interiors and corresponding. What other things can I do? Let me just give you a little bit of a hint. Start drawing parallel and perpendicular lines on these things. Okay? Let me draw a line here. Let me draw a line here. Can I make any assumptions based on what I know? I'll give you another hint. There's a bunch of parallel lines. I got 3 of them on there.
Doesn't that make a lovely right triangle for you to do?
Says the tree grows vertically, right?
Mm-hmm.
Okay. Do we know this angle?
Yeah.
Okay. What would it be, Declan? What's this angle right here?
It'd be 70 degrees?
Close, you're getting there. It's not. This one's 20, right?
Oh, I did 90 minus.
You did the math in your head. This angle is 70,
Oh,
that is 90 minus 20. We now know 2 angles and a side. Is that one of our cheat sheet scenarios for law signs? And in fact, we actually know all 3 angles. So let me just redraw this, get rid of the nonsense. It'll be something like this, where this is 80, this is 50, this is 70, it's 130. That guy's got to be, somebody check my math. Did I do that right?
Yeah, you're right.
Okay. We are looking for this. So let's just label it. Go A, B, C. Therefore, this is B, this is A, that's C. But we are trying to find side A. Should we work through that? I'm going to shut this down so we don't have that. Okay, so it looks like I've got, I got all of B, right? So this is going to be A over sine A is equal to B over sine B. Need to isolate A. So let's get rid of sine A. This goes to 1. I'm left with A is equal to B times sine A over sine B. Let's plug in our numbers. A is equal to B is AB. And sine B which is 60. That's over, oh wait, sine A, sorry, I got the wrong number here. This is 50. That's 60. Correct? Yeah. Okay, we're ready to plug and chug. Majid, when you get the answer, can you let me know what you get?
70.76.
70.76, and that is feet. Don't forget those units, folks. That feet's important. Can I get somebody to confirm that, please? Okay. Let's wait just a moment, make sure everybody can get that answer. Make sure you plug it. If you don't get that answer, please raise your hand and I will come help you. Declan, Missy, and Juan, raise your hand if you get the answer right. Remember, two decimal places. Okay. All right, folks, we're about out of time, so we're going to stop there. Remember, homework due next week. Get with me over the course of the week if you need help. I'll help you on any setup, even though you never called on it today. That's fine with me. If you do need help with the math, I'm willing to do that too, but make sure you have tried it yourself before I do that, because if you show up and you have nothing there, I'm going to ask you to go back and work it yourself first, and then we'll trace through it and find out where you went wrong. We will be in the law of cosines next week, so you might want to pre-read that little section. It's about page 57, somewhere in there of your text. Are there any questions for me? All right, thanks for your time. Rest of the day is yours. I'll see you tomorrow morning.
Thanks, Pat.
Thank you, Ben.
I might just plug you tomorrow, what, from 8 to 10, approximately 8:30 to 10?
Yes, that's correct.
Okay, if I make it by then, I will. If not, I'll come visit you next week.
If you need to see the syllabi for these courses, let me know and I'll email it to you.
Okay.